Hello, my Algebra 2 friends. Welcome back. This is a really important lesson. This is on factoring. So this is the beginning of our factoring experience, and you do have a little bit from your previous math classes. But first, let's talk about the opposite of factoring, which is called distribution. You guys might remember this as foiling. So if you have two algebraic numbers or expressions that are being multiplied together, we know to distribute all the terms together. So a cute mnemonic device they taught you was to FOIL. So F stood for first, multiplying the first terms together. So 2x times x would be 2x squared. And then the O represented the outside terms, but really it's just keep distributing. So 2x times negative 4 is negative 8x. And then we're going to go along with the 3. We're going to distribute that. That's the inner terms. So positive 3 times x is positive 3x. And then finally the 3 has to be multiplied by the negative 4, and those would be the last terms being multiplied together in those binomials. So that's a negative 12. But of course this wouldn't be the end of the problem, because your teacher would point out that you have some like terms that you could simplify here in the middle. So these would simplify to a negative 5x in the middle. So your simplified answer after you distribute everything would be 2x squared minus 5x and then a minus 12. This is called a trinomial. And it is a type of polynomial. It's interesting though, because this binomial times binomial, it's equivalent, right? These are the same thing. It's just in a different form. So I know you're like, why do I care what form it's in? Well, in math, we have to learn how to manipulate something, because then that allows us to continue on and do more work with it in the other form. And that's going to be a big part of our curriculum coming up. So factoring is what we're going to do today, and it's the reverse. So we're going to start with a polynomial, and you got to go backwards and write it as a product, as two things being multiplied together, or sometimes three things being multiplied together. So this is a good image that I stole from the internet, of course. And what does it mean to factor? Well, you're going to take this polynomial and you're going to write it in terms of its factor. So you're going to undistribute it, is what some kids call it. This is a factoring flowchart. This is a simple version of what we will eventually have, something more complicated later. But the idea is you first look for any common terms. Do you have any common terms you can factor out of the problem? And then whether the answer is yes or no, you move down the flowchart. So then what kind of polynomial do you have? Do you have 2 terms? Do you have 3 terms? Because that's all I'm going to give you today. And if it's 2 terms, if it happens to be this very special pattern we're going to run into today, then continue factoring it with that pattern. If it's 3 terms, we're going to do this reverse foiling process called guess and check. Full disclosure, there's other methods of factoring out there. Some teachers use something called slide and divide. Some teachers rewrite it and then like with boxes and do regrouping. And they're all great methods. But because I teach the next level of math, I teach pre-calc, we want you to be really good at factoring and really good at using your number sense. So we're going to teach everything today straight from a sense of number sense. So you're going to be thinking about your options, and it's really just a gigantic puzzle. I'm going to give everybody a copy of this flowchart, or at least provide this to you somehow at home possibly. And you're going to be using this as we practice our factoring skills. So top of the flowchart, look for any common factors. A common factor could be a number, could be a variable, it could be both. So something that both terms could be, or all 3 terms in some cases, could be divided by. And in this problem, I notice that both of these terms have a common x. So what I want you to think about is literally dividing the x out of the problem. What we're really doing is we're factoring it out of the problem. And then tell me what's left. We're going to undistribute it, if you want to think of it that way. So we still have x squared over x would be an x, and then 7x over x would reduce to a plus 7. That is the answer. That is the factored version of that polynomial. I know, seems like too easy, right? So the next question, I'm looking for a common factor, something they both could be divided by. They don't both have an x this time, but they do have an 8 and a 12, which have a common factor of 4. And you want to go as big as possible with your common factors. So I could take a common factor of 4 out, and then it comes out in front of the problem. And then I think about what's left over once I take that out of the problem. Well, I still have a 2x, and then a plus 3. And that's my final answer for that question. I know some kids were looking at that thinking a 2. A 2 is a common factor, but it's not the greatest common factor, so you'd have to continue factoring that question. And then this one, be extra careful. This time you have a number and a variable that it's in common. They can both be divided by a 2, and there's a common x. So as far as common factors go, we can take a 2x out of this problem. And then think about what do we have left? Well, 2x squared divided by x would still leave you with a 1x. I'm just going to write x. And then 12x divided by 2x is a minus 6. Okay, bothering me that I used different colors over here. Now it looks stupid because I wrote over it. Okay, continue on. So that's one kind of factoring we're going to encounter. And oddly enough, as easy as common factor factoring is for you guys, you forget about it because you're so worried about this other kind of factoring we're going to talk about. All right, so here, maybe we don't have a common factor, but that doesn't mean we can't factor. So if I go down my flowchart, it said that if you have 3 terms, something called a trinomial, you're going to do this reverse foiling stuff. Some teachers teach these easier problems as diamonds. We're going to step away from the diamonds here. And we're just going to think of it as a reverse foiling process. So these numbers right here, whatever goes in the first positions, when I multiply them together, I got an answer of x squared. So there's really only one way for that to happen, right? It has to be an x times an x. Now what I'm going to teach you to do, because they're going to get harder in a minute, so follow me, I want you to jump to the end of the problem. The end of this trinomial is what you get when you multiply the last 2 numbers together. So if I think about 4, well, positive 4, the signs can either be plus plus or they can be minus minus. But I'm noticing in this question, and we'll get better at this, but there's only plus signs in this question. So I know my signs have to be positive positive. 4 can be 2 times 2, or it can be 4 times 1. So then you're like, well, which one do I choose? This is where the puzzle comes in. When you take your arches and you add them together, so the arches I'm referring to is this outside and inside, they have to add up to 5x. So looking at my options here, I'm thinking 4 and 1 is what's going to work. All right, this is what I want to see you do though. Oops, I'm using the wrong color. Hold on. And I know some of you are like, I already see it works. I knew this a minute and a half ago. You're slow. Show me this process. We're going to do what's called checking our arches. This arch, if I multiply this arch together, I have a 1x. And this arch is a 4x. And if I add my arches together, 1x plus 4x, I do get a 5x in the middle, which is exactly what I needed. Trust me, this is going to come in very handy in just a few minutes, okay? So check those arches. I want to see you checking your arches. Same idea on this question. There's no common factor, so I'm just going to dive into reverse foiling. And my first terms, when I multiply them together, they have to give me an x squared. So that has to be x and x again. Okay, so this is where it gets a little weird. The last terms, when I multiply them together, they have to give me a negative 40. So right away, as far as signs go, I know I have a positive and a negative. That's the only way for you to produce a negative product. 40. We got problems with 40, right? 40 has a lot of factors. 40 could be 1 and 40, which we'll learn in a minute is silly. Could be 2 and 20. Could be 4 and 10. Could be 5 and 8. I think I got them all. So then again, you're like, which one? Remember, the arches are the last part of the puzzle. When you add up your arches, you need them to add up to negative 3. So as you look at your numbers and you think about which one will make that work, well, it might take you a guess and a check, and maybe you'll fix it. I promise, guys, it won't take you more than like 3 on the harder ones even. 8 and 5 are going to work as long as you make the 8 the negative one. Let me show you why. This outside arch is a negative 8x. This inside arch is a 5x. And if I were to add these together, I get negative 3x. So checking those arches is extremely important. If you put the negative with the 5 instead of the 8, you don't have the right factoring puzzle, so we do have to be careful about that. All right, let's try one more of these. And then we'll step it up a little bit. So same idea, the first terms being multiplied together have to be x squared, so those individual pieces have to be x and x. Oh boy. This one always tricks kids. Okay, so multiplying to 12, my signs have to be the same in order to get a positive product. So it could be plus plus or it could be minus minus. So as I look ahead in the puzzle, I notice my arches have to add up to a -8. That tells me I have to use two negative signs. Negative, negative. Signs are usually where kids have the biggest struggle, and the kids who then don't go and check their arches have a lot of struggle. So get in the good habit. All right, let's talk about our options for 12. We got 1 and 12. That's not going to work. Then usually you guys start rattling off. Why am I using green? 6 and 2. And then 4 and 3. I mean, I'll write down 12 and 1, even though we know it's not right. And then I think about what will work for my arches. And I'm thinking 6 and 2. Because, and it doesn't matter who's going where, because they're both negative. When you check these arches, this arch is a -6. And then x times -2 is a -2x. And when you add up those arches, you do get a -8x. So there we go. Checking all the factoring puzzle. It's about to step up one level of difficulty, okay? So hopefully you were able to follow along with those. Yes, knowing your multiplication facts really well helps, but it doesn't mean, you can't do these questions if you feel like you messed that part up. It just means you're going to go a little slower. That's okay. All right, these are going to be a little more difficult because you'll notice the first terms are not a 1x squared. So let's talk about why that does make it a little more difficult. So this time, when I multiply my first terms together, this guy times this guy, it's got to give me a product of 2x squared. Well, it doesn't really make it that much more difficult, but instead of 1x times 1x, it would have to be 2x times 1x. The good news is that's a prime number. So there's only one way to make that work out. Same idea, we jump to the end of the problem here, and I have to multiply two numbers together, and they have to multiply to a +3. What some kids like to do on these questions is they like to put like multiplication stars at the top here, and then they like to put an addition symbol above that. I find sometimes that helps some and hurts others, so you decide what's best for you. All right, so if I'm multiplying to a positive number, I know they have to be the same sign, so either plus plus or minus minus. And if I look ahead in the question, it's all plus signs. So that tells me I need to put a plus plus down. Good news, 3 is prime. So it's 3 and 1, but where I put the 3 and where I put the 1 is going to make a big difference. I'm going to intentionally mess this problem up the first time, okay? I'm just going to put down 3 and 1. And for a kid who doesn't check their arches, this is where they're going to get in trouble. This arch right here is 3x. This arch right here is 2x. 2x times 1. If you were to add those arches together, you get 5x. I don't need 5x, I need 7x. So let's see what happens now. And if this was like your practice, I wouldn't suggest you erase your answers. I would instead suggest you just kind of cross them off and try another one so you can kind of see your struggle. It does help, and it also helps your teacher see your struggle, because if the issue was, you thought 2 times 3 was 5 instead of 6, then I can see your struggle and I know what you're battling, okay? So speaking of that, what if we put the 3 here and the 1 here? So 1 times x would be 1x, and then 2x times 3 would be 6x. Those arches now add up to 7x, and that's how we're going to get that puzzle to work out. So showing the binomials, showing that you're checking your arches, that's what I want to see on your practice work. And the fun continues. All right, here we go. 3x squared. So again, it's prime, so that's kind of nice. There's only one way to get a 3, 3 times 1. So as long as you put x's on it. Oops, not that though. All right, 3 times 1. So 3x times 1x. And then at the end of our problem here, it's got to the ends have to multiply to a +10. So again, positive product means I need the same sign, either a plus plus or a minus minus. And if I look ahead in the question, I notice it has to add up to a -17 on the arches. So I'm going to have to use 2 negative signs. Now for 10, you got 10 and 1, and you got 5 and 2. I have a lot of advice as far as factoring goes. My first piece of advice to you is when you have an option and you really don't know what direction to go, don't choose the numbers that are really far spread apart. This really big range produces really big arches. So unless you want a really big arch in the middle, you don't pick that one. especially if you're just guessing. So I'm going to go with 5 and 2. And maybe still, I don't know. Maybe I'm just throwing them down. So maybe I just go 5 and 2. And I check the arches to see if it works out. Because remember, we're trying to add up to negative 17. Now, I know you're out there going, don't do it. This doesn't work. Let's show everybody why it doesn't work. This arch is a negative 5x. And this arch is a negative 6x. And you're right, that does not add up to negative 17. So I don't say, oh my gosh, I screwed it up. It's not 5 and 2. It is 5 and 2. It's just in the other order. So looky here. This arch is now a negative 2x. And this arch is a negative 15x. And when I add those arches together, I totally get a negative 17x, which is what I needed in the middle. So we call this the guess and check method, essentially. It's reverse foiling, but guess and check. And there is a little bit of guessing. There's still questions that I have to guess on. Sometimes I try to save face and do all the guessing in my head, and it backfires. So my next piece of advice to you as you practice this, throw something down on the paper, check it. If it doesn't work, just keep going. Keep going, keep going. Because the worst thing you can do is go, I can't figure it out, Mrs. Abruzzo, and you've never tried anything. If there's no pencil to the paper, I don't believe that you've actually tried anything, okay? All right, there's no common factor. I should be checking that first. But we do have to reverse foil this one. Now this one, a little tricksy. 8x squared, that is no longer a prime coefficient. So 8x squared could be 8x and 1x, or it could be 4x and 2x. So I'm going to go back to that previous piece of advice I gave you. We shouldn't pick the numbers that are really far apart typically. So if I'm just guessing, which even I'm guessing right now, guys, I'm going to go with the closer ones, 4 and 2. So I'm going to put down 4x and 2x in the leading positions. Sorry, I have a loud family. Okay, so now we're going to move on to the end of the problem. And I need my last numbers to multiply to a negative 9. So first thing I notice is negative means I need two different signs. I need one positive and one negative. I'm not really sure where to put the signs. And my co-teacher, Mrs. Meyer, she's really good about not putting the signs down yet, and she'll just put them down later. I'm not that good. So I'm just going to throw signs down because, I have something that I can erase easily, and I'll fix it if it's wrong. So let's talk about the number 9. 9 is 9 times 1. 9 is also 3 times 3. So again, my piece of advice, not using numbers that are spread out, but also 3 and 3 I like to try first because you can't reverse 3 and 3. So putting down 3's and then checking the arches. And this is where I accept I probably made a mistake and I'll fix it later, right? So this arch, 3 times 2x is a 6x. And then this arch, ooh, I didn't make a mistake. That was lucky, is a negative 12x. And when I add those arches together, I get a negative 6x, which is what I totally needed in the middle. So I lucked out. I was essentially guessing on, they were educated guesses. They were guided by experience. But the worst case scenario is maybe I had to make 1, 2, maybe even 3 guesses until I stumbled on the right answer. It's okay. All right, this next problem really throws kids because they're like, well, it doesn't look like the other problems we've done. So how can we rewrite this so it follows that same pattern? Well, the thing I'm noticing is there's no x in the middle. Like the arches term, there's 0 x's in the middle. So what you're looking for here are factors where the first terms multiply to x squared. So that's back to the easy ones, right? My last terms multiply to negative 36, but my arches have to add up to 0. That's what I'm looking for. So I don't think it's that bad. X squared would be x and x. And then I'll agree with you, negative 36 has a lot of factor options because it's positive and negative. And then 36 has a gazillion different factor combinations. But if I need my arches to add up to 0, that means they have to be what are called additive inverses. So 6 and negative 6. And if you don't believe me, check the arches. So this arch is a 6x. And this arch is a negative 6x. And when you add those up, you get no x's in the middle of the problem. So you're probably thinking like, ugh, do I have to write that out every time? Like, I have to rewrite it with a 0x in the middle? And the answer is no, because this is a very special pattern. This is my favorite pattern in factoring. It's called the difference of two perfect squares. So you'll notice it's on your factoring flowchart. If you have a subtraction problem And both of the numbers are what we call perfect squares. So perfect squares would be like a variable squared would be x squared, or a squared, or b squared, or y squared, or whatever. A number that can be square rooted would be called a perfect square. So things like 1, 4, 9, 16. And there's even a chart on your factoring flowchart of this, or a little box, cheater box there. So if it falls into this pattern, the pattern works the same way every time. What you do is you take the square root of the first term and you put that number here and here. And then you take the square root of the last term and you put that number here and here. And then the way the signs work is you got 1 plus and 1 minus. Mrs. Meyer and I, when we're co-teaching this, we call this the good twin, evil twin pattern. So they look like twins, but one's positive and one's negative. In math, they're called conjugates, but we thought good twin, evil twin was a little more fun. All right, so here definitely follows that pattern. You can go through and rewrite it with a 0 in the middle like we did on the previous one, but I don't think we need to go through all that work, guys. So the square root of this would be x and x. And then the square root of 9 would be a 3 and a 3. And the way the pattern works is you make 1 a plus and you make 1 a minus. Go check your arches if you want, but this pattern's really nice, right? So same idea here. There's no common factor. I keep forgetting to check for that. It's going to get me in trouble in a minute. But it does follow this perfect squares pattern, difference of perfect squares. So if you take the square root of this first term, you got to square root the 4 and the x squared this time. That would be a 2x and a 2x. And then if you take the square root of 81, that would be a 9. Again, the way the pattern works is 1's plus and 1's minus. That is my absolute favorite factoring question. If I saw a whole page of this for homework, I would do a little happy dance because they're amazing, right? I mean, not much in math is so beautiful. Now, here's some other patterns that you're probably going to encounter in math. I just don't know that they're worth like your brain energy in memorizing right now. But if you happen to recognize them, they are nice shortcuts. We are going to use these in reverse later on when we do something called completing the square. But here's how these are different from the previous pattern. The previous pattern had a plus and a minus factor. These patterns are going to have the same sign. So these are called perfect square trinomials. And this is the pattern you're supposed to recognize. Most kids don't. But what I can ask you to recognize is that if you notice your first term and your last term in the trinomial are perfect squares and there's something going on in the middle, then you probably have this pattern where it's like literally the same thing shows up twice. So if I want to go factor this guy, and I'd think, oh, what times what gives me 4x squared? Now, that has more than one option, right? It's got 4x times 1x and 2x times 2x. But because I recognize that it's got a couple of squares in the problem, I'm going to use the 2x and the 2x. And then for 9, again, there's a couple of options for 9 factors, but because I see the perfect squares pattern showing up here, I'm going to use 3 and 3. And then both positives. Now watch what happens on the arches here. You get the same arch. You get positive 6x, and then you get another positive 6x. And if you add two 6x's together, you get 12x, which is what we wanted in the middle. So that's where this part of the pattern comes in play. It's 2 arches is what that literally says, 2 of a times b's. I don't know how important it is for you to memorize this pattern. I think it's more important that you recognize your perfect square showing up. Probably means that you need the square factors. Square root factors, I should say. All right, so same idea here. The only difference here in this pattern is they're both going to be minus signs because you're going to have a negative 2ab in the middle. So factoring this, 25 has a couple of options, but I'm going to be smart and go the square root route. I'm going to call that 5x and 5x. Again, 4 has a couple of options. It's positive, so I need the same sign, and I need my arches to be negative, so that means I need 2 negatives or subtractions. And then I'm going to use the square root factors of 4. I'm going to use 2 and 2. And then, lo and behold, look at our arches. We got 2 of the same arch, so negative 10x, and then another negative 10x. And if you add 2 negative 10s together, y'all get negative 20x, which is exactly what we needed in the middle of our puzzle. So those are fun, right? Let's put it all together now. Sometimes you gotta do more than one type of factoring. So we call these layers, and these are probably the trickiest questions for kids because there's just so much going on. And kids really struggle through the questions if they don't use the flowchart order. You have to look for common factors first. I get a lot of kids who never do that. And then they end up getting the question wrong because they're not completely factored. And then also, kind of sad, they end up spending like twice the energy trying to factor it because it's so difficult. Like right now, I'd be like, oh, 5. Oh no, it's one of the hard ones. No, because look at the question. You've got a 5, a 20, and a 15. All of those have a common factor of 5. So you can actually, just like we did on the first few questions, take out the common factor of 5, and you get a brand new trinomial. You have an x squared plus a 4x plus a 3. Now we're not done. That was just the first layer of factoring. If I move down the flowchart, I have inside the parentheses, and now I have a 3-term trinomial, which I can try to factor again using that reverse foiling process. So keep that 5 in front. And this is going to get tricky because I don't have enough colors here. Let's talk about this guy. X squared has to be x and x. Multiplies to a 3. That's got to be 3 and 1. And then the arches have to add up to a 4, positive 4. So what if we used positive 3 and positive 1? That would work, right? I still want to see you guys checking your arches. You just have to be careful and remember that these arches, hello, that's an X, okay. These arches are adding up to this middle term because remember you took that 5 out of it. It's not gone from the problem, it's just factored out of the problem right now. And this is your final answer. Now a kid will argue with me that they wrote down something like x plus 3 times 5x plus 5 and they're like, I have it right, I have it right, I have it right because I checked my arches. And my issue is it is not completely factored. They left the 5 inside of the factor and they struggled through the question and they never fully factored it. So it's not right. All right, this next one, we have a common factor again. Surprise. We have a common factor of 2. So if I take a 2 out of this question and leave it in front, now I have x squared minus 16. And then I do a little happy dance because that's one of my new favorite little difference of squares pattern. Notice that is on your flowchart. So difference of 2 squares is this guy right here, the good twin, evil twin pattern. Be careful, you got to keep that 2 in front. And then remember the way this pattern works, it's late, sorry. We have to square root each term and then make one a plus and one a minus. So square root of x squared would be x and x. That's this guy. And then square root of 16 would be 4 and 4. And then let's make one a plus and one a minus. You could check your arches. I don't really usually go to the effort of checking my arches because it's so stinking obvious in that pattern that the arches will be 0. But you're welcome to. Oh, and that was the last one. The rest of it's going to be your homework, and I don't want to do that for you. Factoring is probably one of the most important things that we are learning right now in Algebra 2 because it carries through so much of Algebra 2 and then it goes on to trig and pre-calc and calculus and everything that you encounter in math from here on out. It's a very big concept on the SAT test and it's going to carry through, like I said, even just for this year. So if this is your last, stop on the math train, factoring is not one of those things that will go away. So it requires practice, practice, practice. Your fluidity in factoring will come after you practice. It's not a passive sport, this math. You got to practice. All right, good luck, everybody.